In this lesson, we're going to be looking at the graphs of cubic root functions and how they are transformed. So just like square quadratic functions, the inverse is the positive part of the inverse is the square root function. If we were to find the inverse of the cubic function, the result would be this cube root function. All right, and the graph of the inverse, as you can see, it's a mirror image across the identity function, across the line y equals x. So the inverse is also a function. The inverse of a cubic function is the cube root function, which is also a function. So you should be able to identify the domain and range. The domain and range is always going to be all real numbers, from negative infinity to positive infinity. The inflection point for the parent graph is 0, 0. If x is 1, then the cube root of 1 is still 1. If x is negative 1, cube root of negative 1 is negative 1. And as x approaches positive infinity, y is going to also approach positive infinity. As x approaches negative infinity, so will y. Transformations are still the same as the last lesson, as well as the last couple units ago when we looked at the transformation of quadratic and cubic functions. And then the inflection point we get from h and k. H is negative 7, k is negative 20. Should do a quick sketch of the graph. That's what the parent graph looks like, but because a is negative, it's going to be vertically reflected, and it's going to look like this. The inflection point, again, is identified by h and k. H is negative 7, k is negative 20. And then to describe it, we're going to start with the negative. Again, the negative is reflecting it vertically. And then the 7/9 is going to compress it vertically by 7/9. The positive 7 is going to translate it 7 units to the left. And the negative 20 is going to translate it 20 units down. Another example. Again, start with a quick graph of the function. This is what the parent graph looks like. And because the x inside the up under the cube root sign, because it's negative, it's going to reflect it horizontally, making the graph look like this. The inflection point is still determined by h and k. H is 0, k is 1. And so the negative inside up under the radical sign is going to reflect it horizontally. And then the 1 is going to translate it 1 unit up. All right, so for this one, again, we want to start with a quick graph. All right, it's going to look like this because it's not being reflected. The domain is going to be all real numbers, so will the range. As x goes to the right, y continues to go up and up, so positive infinity. As x goes to the left, y continues to go further and further down, so negative infinity. Inflection point, h is 0, k is 2. If x is 1, cube root of 1 is 1, 1 times 3 is 3, 3 plus 2 is 5. If x is negative 1, cube root of negative 1 is negative 1, 3 times negative 1 is negative 3, negative 3 plus 2 is negative 1. And one last example, the domain and range for all cubic functions is going to be all real numbers. And this is what the graph looks like because that negative b is reflecting it horizontally. And then as x goes to the right, y is going down, so it's going to approach negative infinity. As x goes to the left, y is going to continue to go up, positive infinity. The inflection point is h comma k. H is 4, k is 3. If x is 5, 5 minus 4 is 1. Negative 1, it would be our radicand. Cube root of negative 1 is negative 1. Negative 1 plus 3 is 2. If x is 3, 3 minus 4 is negative 1. Negative negative 1 is 1. Cube root of 1 is 1. 1 plus 3 is 4.